In problem 4 here, we're going to conduct a hypothesis test on the standard deviation of video game play. So we're looking at different ages versus video game play. And we are comparing 14-year-olds and 18-year-olds. Those are our two populations. Representative data for the study is given here. So our 14-year-old gameplay, we've got 10 data values there. And our 18-year-old gameplay, we've got 10 data values there. So N1 here is equal to 10. And N2 is also equal to 10. So both samples have the same size there. Can you conclude that the standard deviation of the daily gameplay is greater for 14-year-olds than for 18-year-olds? We're going to let sigma 1 denote standard deviation of gameplay for 14-year-olds and sigma 2 the same for 18-year-olds. So we're asking, is sigma 1 greater than sigma 2? That's going to be our alternative hypothesis. So sigma 1 greater than sigma 2. And then the null hypothesis, if that doesn't happen, is we're just going to assume that they're the same. Sigma 1 equals sigma 2. Is a hypothesis test left tail, right tail, or two tail? So greater than is going to be right tailed. So let's sketch our distribution curve and our rejection region. So F distribution looks like this. We're testing at the 0.01 level. So our rejection region over here has got area 0.01. So this critical value is F 0.01. So 0.01 is the right area again. And if our test statistic is greater than F.01, we will reject H0. So that's the rejection region. So let's go ahead and find our critical value. And we'll round to 2 decimal places. So let's go to the distribution calculator. Again, you can use the table if you want to. Our value of alpha here was 0.01. And then degrees of freedom numerator and denominator. Well, both the sample sizes are the same, so it doesn't matter what's numerator and what's denominator. N1 and N2 are both 10, and 10 minus 1 is 9. So both of these will be 9. And that gives us a critical value of 5.35. So let's see here. Right here we've got 5.35. Is our critical value. So now we need to find that test statistic and see if it's more extreme than 5.35. So compute our test statistic. That's going to be the larger of the two variances divided by the smaller of the two variances. So we need to find those variances first. So find the standard deviations first, and then we'll square those to get the variances. So we want to take and enter this data into the TI-84, and I've already entered that data for us. So let's go there. So here's our calculator with the data for 14-year-olds and 18-year-olds entered in list 1 and list 2. So we want to go to stat and calc and one variable stats. And list 2 is already in there. Let's go ahead and do that. That'll be the 18-year-old data. So come down to calculate and enter. So the 18-year-old data, S sub x is 36.2370. So 36.2370. And then let's do it for the 14-year-olds. So again, we're going to go to stat, then calc, one variable stats, and now we want list 1 in here. So second of 1, we'll change that to list 1, highlight calculate, enter. That standard deviation 65.8581. 65.85. Need a little bit more room there. There we go. And if you square that 65.8581, you get 4337.28. Square the 36.2370, round to 2 decimal places, 131312. So we put the larger variance on top. That's the 4337.28. Smaller variance in the denominator, 131312. And we divide those two and we'll round to 2 decimal places. So when I did that, I got 3.30 to 2 decimal places. So 5.35 out here, and then the 3.30 would be about right here. So our F test statistic is 3.30. So notice that that is not in the rejection region. We need it to be greater than 5.35. It's less. So our F test here is 3.30. It is less than 5.35. So we do not reject. So we're going to conclude that there is not sufficient. So there is not enough or not sufficient evidence to conclude the standard deviation for 14-year-olds is different than the standard deviation for 18-year-olds. So that is a hypothesis test for difference of standard deviations when it's a one-tailed test and the sample size is the same. So it's a little easier when the sample size is the same. You don't need to figure out the test statistic first because numerator and denominator degrees of freedom are the same.